welcome back. This is a video for our second lab. For our first lab, we investigated constant velocity along the horizontal portion of our track. For our second lab, we are going to investigate a constant acceleration down the inclined plane portion of our track, using the same setup that we used during our first lab. So this past week, we have taken a look at our three kinematic equations, given some variables and asked to solve for other variables. For this lab, we are actually going to be using graphs to find those missing variables. So we've used equations to find the variables that are missing, and now we are going to be using graphs to find these variables that are missing. So the purpose of this lab is to investigate constant acceleration down the inclined plane. The skills that we are going to be practicing with this lab are data collection and graphing analysis. And the equipment we're using for this lab is the same equipment we used last time: our marble, our meter stick, our two pieces of track, and the block to create the inclined plane. Things that we are going to measure for this lab are displacement using our meter stick and time using the video. If we were in class, you would be using your phone as a stopwatch, or you could be using video analysis. All right, data we're going to be collecting for this lab is going to be short and very similar to what we did before. So for this lab, we're going to be looking at the motion for the whole path traveled. So we're going to be looking at the motion while it's accelerating, and we're going to be looking at the motion while it's moving with a constant velocity. Because there are two separate motions here, we are going to have two separate data tables. We'll have one data table for our portion that it's accelerating and a separate data table for our portion that is moving with a constant velocity. So I have marked out for us 1 meter along the incline. So this is going to be our position 0, 20 centimeters, 40 centimeters, 60, 80, 100. And then along our incline, or our horizontal surface, we have another meter. So our 100 centimeters, 120 centimeters, 140 centimeters, all the way up to 200 centimeters. And of course, with our equations, we have to convert our centimeters into meters. So the full length is going to be 2 meters long. So our data we're collecting is the time it takes to go the 20 centimeters, time it takes to go 40 centimeters, time it takes to go 60 centimeters, time it takes to go 80 centimeters, and so on. So the data collection is the same thing. I'm just gonna release my marble from position 0. So our initial position, or our x sub naught, is gonna be 0 meters is how we're gonna identify that. Okay, so here we go. I'm gonna do it 4 times so that we can take our average time for each displacement interval, so that we can eliminate any uncertainty in our data collection. And the data portion of this is not super long, but we are going to spend quite a bit of time graphing and using our graphs to talk about our unknown variables. That's it.